Hello everyone. Our stretch assignment number 7 asks us in the first question to demonstrate to stand up a PKI public key infrastructure chain. Before standing up the PKI chain, first of all, I would like to just give some brief introduction that why this securing of data medical device is important. So this is basically a presentation from HIMSS 2017. So this was a pertinent presentation. So they say that because there are a number of security issues, vulnerability issues in medical devices, so electronic secure data needs to be assessed, and a technology such as PKI should be uh, incorporated. Then later they said that FDA's guidelines are there for medical device protection, and they say that manufacturers are encouraged to address cybersecurity throughout the product lifecycle, including during the design, development, production, distribution, deployment, and maintenance of the device. And routine updates and patches needs to be fixed. Why PKI Public Key Infrastructure Framework is important? It's because it's a comprehensive framework that contains the set of rules, policies, procedures needed to manage, distribute, create, store, use, and revoke digital certificates. We would just demonstrate all these functionalities in this demonstration. Device authentication is possible with access control and identity fabrication device, and it's basically cryptographically secure. Also, it's in data as encryption, whether it has transit, at rest, or in process, and system and data. And both system and data integrity is possible because secure boot, configuration setting, IP protection, and integrity of data coming to and from device is possible through this. So let's now divert our attention towards uh, our this demonstration. So I've installed this um, Ubuntu on my VirtualBox. So here are my terminal where I have executed various commands. I just basically followed a tutorial from this page, which helps us to construct a simple TKI infrastructure. So at its root, first of all, we have created a root CA, and then that root CA is signed, and then signed using that signed CA, an email is a certificate is generated, and also a TLS certificate is generated. I've shown this process here in the terminal. So various commands I used for this. First of all, I just cloned the directory and got the example one running here this command, and then clone it, and then I used various command where I created the database, and I then created a new certificate using this command. So that was created, and then I given a PAM passphrase, and certificate details created were then shown here, which says that this is number one, serial number 1 certificate, and it's valid before 27/19 at this time and not after this. And some domain components and domain organizational name were structured here. So then certificate were certified for that particular time period, and then later I used some more commands to create this signed certificate. So as I mentioned before that first we get a root certificate, then we signed then signed those certificates, and then email was a certificate by the email. Now once the CAs are in place, we issue an email protection certificate to apply, where instead of Fred Flintstone I given my own email address, which I can show you here. Here I given my own email address, so this certificate will be issued to that, and then this certificate is signed. Once the certificate is signed, now we can use the commands to view the output. So here, coming to this output section of this I run all these commands. So to view the results that what we created the certificates and how those certificates were signed. So to view certificate, I'm using this command, which is X509 command. So the created certificate can be used. So let's just command here and just so so here we have the certificate. So certificate request was made, data version, it's version 0, subject. So this was various elements we provide, and here I mention my own name, and it's basically subject to public key information, public key algorithm, RSA encryption is used, and public key 2048 bit was used, and its modulus was created, and this is other certificate information. Now moving ahead in the tutorial, we can view CRL information. So here we can view certain bundles which we created before. So these bundles just bundle various certificates. So it's version 3 because it was updated, and serial number is 1. This is hexa valued, and SHA-1 with RSA encryption was the algorithm. So this is the output for the PK CS7 bundle. So at last to view uh, PKCS12 bundle output. So I just hit the command. So yeah, this again shows us that this is the bundled certificate. This is the output for that. So yeah, using that simple tutorial, uh, and following this simple tutorial, I was able to just stand up a PKI chain which had basically a root CA and signing of the CA, and then I used my own email address for once the CAs are placed, an email protection certificate was issued to me because I gave my own email address, and then TLS server certificate was also issued on this simple org site, and then we finally looked some of the outputs represented here. So this is So next task or next question is to connect two virtual machines on VirtualBox together so that they could be pinged from one another using the IP address within some range. So here we have a VirtualBox manager. So I have two machines. One is server machine, another client machine. So I've named it appropriately. One is server machine, another is client machine. So to make them accessible from within each other using an IP address, we have to do certain settings first. So first we need to do some settings for server. So here comes server. So we have to go to network, and we have to select this network, NAT network, and test network. So this test network I have already created, which is referenced here, which is placed here. So how to create this network, test network? So go to file, go to preferences, and then here we create a new NAT test network. So I'm here in network, so I've created test network. So how I created basically, so I just gave it a test network and placed a network CIDR, and I placed an IP that could be any IP. So I placed it 172.26.1.0/24 as CIDR.
So this is how I created my new test network. So let's go ahead and do it. Okay, same procedure for placing the IP address and giving it a network, a NAT network I did with client machine. So went again to settings, then network and NAT network. Again, this is test network, which I just described it how I created this test network. It is also referenced here. So so now my server and like client machine both are running on same NAT network. So when I would run actually on terminal, I would just show that how using an IP address line within this range we can access any of this server, any of this machine from one another. So I started both of these machines. So let's go here, and this is my server machine. So I'm going to log in here. So this is my server machine. And this is my client machine, so it's booting up. It would take some time basically.
So our two client and server machines are up. So here we are on our basically server machine. So let's check the IP address of this machine using ifconfig command. So ifconfig command gives us the IP address, which is internal address of this, which we given at creating the new network, NAT network. We given this particular IP address, and that we got here. So this is our IP address for this server machine. So let's just do a quick test that whether we are able to connect our client machine, which is this, given this particular IP address, which is this address from our client machine, and we would be pinging from our client machine to this server machine using this IP address. So now let's move to our client machine. This is our client machine. So let's now ping from our client machine, and here this is our client machine. Ping 172 dot what was the address? Let's look again. 26.1 26.1 and 2.26. It's stuck. Let's wait for a second. 26.1.4. So let's confirm that this was the IP address we're pinging here. So it's pinging, and yeah, it's getting the data. Let's say 65 bytes from this ICMP and this timer. So all this data is coming from the server machine. So yeah, we successfully connected from our client machine to server machine. So let's do the same with our server machine, and this time we would just give this IP. We would uh, just give another IP from within this range. 172.6.26.1.2.4, 172.26.1.255. So I would give an IP within this range from the server machine to connect to our client machine, and let's see that are we able to connect or not. So 172.26.1.5. So, and yeah, we were able to connect with that, and we were able to get the data from our client machine. So let's now, so yeah, we were successfully able to demonstrate the how we can connect two machines, as I discussed before. Two machines from one was our server machine, and the client machine. How we are able to do how we are able to connect these two machines with each other, and just run or ping both machines from within each other from from within terminal, from within individual machines to connect with each other or ping the data from one machine to another, like from server machine to client machine. And then I showed how we can do the same from client machine to server machine. So yeah, now next moving to the next question, which is basically which says us to that how these demonstrations have an impact for securing the healthcare data or healthcare devices. So first we see, so I have created this particular demo which I would be uploading on the YouTube, and then I would pasting that YouTube link here on this presentation, and I would submit this presentation also on Canvas. So why PKI or public key infrastructure is important? Public key infrastructure is a comprehensive framework that has very secure features because it can provide rules, policies, and procedures needed to manage, distribute, create, store, use, and revoke digital certificates. So using these digital certificates, we can secure our nodes. So the data on two nodes can be secured using the policies and privileges on the roles and privileges assigned through this PKI public key infrastructure. So these demos are important because they demonstrate that how device security is very important aspect when it comes to healthcare data, when specifically it comes to device integration or device to device monitoring. The data is just getting from one node to another node. Is that data is securely transmitting from one node to another node? Is that device has that specific or enough security measures on either sides to protect that data or not? So this PKI infrastructure, public key infrastructure, can be very helpful in this regard because it basically mutually it authenticates all the connections using the PKI public key infrastructure, and through certificates it can manage access control, that who is able to access or who has been granted the access to manage a particular device or log into a particular device or access a particular device or use a particular device. So applying an identity fabric on device is very much manageable and easy and through this PKI, and also cryptographically because it involves the implementation of cryptographic algorithm like SHA and RSA, so it also is cryptographically very secure. Also, it mutually authenticate for all connections, and PKI can help basically in a preventative stance. So it prevents rather than to when actually a threat happens, to just investigate and just counter that or just treat that threat. It basically prevents the any security malfunction or malicious security action, or even in the case of before that malicious action or even just happened. So yeah, this was my presentation for so now coming back to PKI. So public key infrastructure is basically a triangle where security solution for connected devices at middle, device authentication and data and system security and data encryption are and the sides of or on the vertices of these on the three vertices of this triangle. So this is a presentation I'm just referring here because I retrieved it from HIMSS Health Information Management System Society of 2017 conference. So this presentation was presented there. So I'll just give it due a reference or citation at the end of my original presentation. Now, because medical equipment security is very important, FDA regulates this, and FDA has said this that uh, complying with medical equipment security or securing medical equipment end to end is really need of the hour. So identification of asset stress and vulnerabilities, it's very important. assessment of the impact of threats and vulnerability on device functionality and end users or patients, assessment of the likelihood of a threat and of a vulnerability being exploited, determination of the risk levels and suitable mitigation strategies, and assessment of residual risk and risk assessment criteria. So all these features needs to be taken care of when it comes to medical equipment security or medical device security. PKI, public key infrastructure, is very important because it complies to all this and provides all these features. So it starts from risk assessment and then just labeling those risks into low, medium, and high, and then it comes to medical device risk, specific risk assessment. That so each and every medical device doesn't have a uniform or the same risk. Different devices may have different risks, so we have to account, or uh, we have to just cater for all these devices. So yeah, that's why these demos are important, and these PKI public key infrastructure is very important when it comes to security.